Hi, I'm Carl Franklin. In this episode of Blazor Train, I'll show you how to use Azure Blob storage as a back-end data store. Now, I know what you're thinking.
You're stupid!
Carl, why on earth would you just save data to blob storage when you have so many powerful databases available to you in Azure? Well, it turns out that there are some scenarios where using a relational database is like swatting a fly with a Buick. I happen to need this architecture because I manage data for podcasts. For years, I've been keeping the data in Azure SQL Server databases, but it turns out that's been expensive and just not necessary. First of all, there's very little data, maybe 4 or 5 megabytes. Secondly, there are only 2 people in the world that update the data, and usually only once a week. So now I'm going to be giving up some of the nice features of SQL like automatic backups, but those things can be done manually as well. So if you've got lots of data that's being updated frequently, this is not a good scenario for you. Carry on with what you're doing. If, however, your criteria fit mine for podcasts, you might be interested in this approach. For today's demo, we're going to use the repository pattern just like we did in episode 16, Data Access. In fact, we'll use the same exact architecture, even revisiting the generic Entity Framework Manager. And that's all coming up right now, right here on Blazor Train! So, as Carl said in the intro, we're going to revisit episode 16 of Blazor Train, Data Access, in which all of the components of the entire API layer to the back end were created with the repository pattern. And we're going to implement on the server side in a Blazor WebAssembly hosted application, we're going to implement a data manager that rather than using Entity Framework to talk to databases, we're going to be using Azure Blob storage to use blobs, to read and write JSON files that are stored as blobs. So this scenario isn't recommended for most situations, but it turns out that my situation I'm using it for is perfect. As you know, I have a podcast called .NET Rocks, and every week we have somebody new on there, and so there isn't much writing to the database. You know, every time we have a new guest, we put the guest in there. Every time we have a new show, we put some show notes in there, but it really only happens within the span of an hour or so every week. And it's usually either me writing or Richard writing. There isn't much chance of collisions. There's not a lot of writing to the database because it's mostly read-only, right? When you consume the podcast, we use all that data to get into the feed. So this turns out to be the perfect scenario where we want to save costs on SQL servers and things like that and use the cheapest form of storage that Azure has to offer, which is blob storage. Now, I've created a GitHub repo for this code right here, which is the first time I've done this for code, I believe, in Blazor Train. I'm going to try to go back through all the episodes and create repos with all the sample code and that kind of thing too. But you can go to this GitHub repo, and it's not only a good reference for blob storage, but also for revisiting all the data access stuff that we did before with the repository pattern. So this is a really good example of how to access data all the way through, even if you're not using blob storage. Okay, so let's get started here. I've created a WebAssembly application called Blob Repository Demo, and as you can see, it's got the client, the server, and a shared project, just like we always do. And I'm going to add a models folder, because we're going to start with a model, of course. Into the models folder, we're going to add a model called Customer. And so now you can see customer has an ID, as an integer, it has a name and an email. Something really, really simple. Next, we're going to add those models that we used for the API response. And this is a way that we can add a little bit of context around every response that we get back from an API endpoint. So these are going to be API entity response and API list of entity response. Here's API entity response, which takes an entity type, and this is just a class, so whatever, we can make this an API entity responsive customer, right? And now we have a Boolean for success. We have a list of error messages that we can set, and we also have the data that gets returned. And here's API list of entity response, and this is for returning an IEnumerable of T entity, and everything else is exactly the same. So this is when we're returning more than one, and the first one, API entity response, is when we're just returning a single entity. Next, we want our interface for a repository. Now this one's a little bit different from the one that we created in episode 16. We've got this guy right here now, delete all. And I say be careful because you don't want to implement this if you're going against a production database. We've got our get with filters, right? So you can query that. But we also have a get all in case you don't want to use this, just to return everything. And we have everything else the same. Get by ID, insert, update. You can delete by the entity or by the primary key, which we made an object, so we can accommodate integers, GUIDs, whatever you have. Now I'm going to start off by making a data manager that implements iRepository, but just keeps everything in a collection in memory. So this is going to be called a memory data manager. And we're going to create a data folder on the server side and add our memory data manager class to it. So this is an implementation of iRepository of T entity. So there's some interesting things going on here. First of all, we have our list of entities, data, and we've got this ID property name that is getting passed in the constructor. And so we get that ID property name, and then we use get property on the type to get the property info object so that we can actually use that to get values and things like that later on. So here's a typical implementation, right? Delete. We have our entity to delete, and if it's null, then we want to return false because it's already deleted apparently. I've again got this await task delay 0 in here because there isn't any other await statements, and we want this to be async, so we don't want the compiler yelling at us. So if the data list contains the entity to delete, we're going to remove it, return true. No matter what else happens, we're going to return false. And then the delete with the ID calls get by ID to get the entity, and then calls the entity delete that we just had. Now here's our delete all. Now this is in memory, so it's for demo purposes. We can have a delete all. It's good because now I can clear everything else to show how the data is built up and how we can just reset it easily. Here's our filtered get that takes an expression, ordered by, included properties, right? So this is really great, especially if you're using something like Entity Framework. You can just do queries in your controller to return specific sets of data based on their, what they are. Get all is just going to return data, all the data. Now here's where we use that property info, get by ID. So the ID property, remember that's our property info object. Now we're pulling out this entity and we're looking at the property type. If it's a value type, then we're going to do a toString on the property value. Now, I have never seen a situation where somebody uses a non-value type as a primary key. I can't imagine it, but I put it in here anyway, just because I want to show you that you can actually query to see that if the property type is a value type. Both an integer and a GUID are value types. So we shouldn't even ever hit this line of code where we're just comparing the value to the ID that's passed in. but we're using toString, right? To see if getting the value of, the item in the list is equal to the ID, but we're using toString to compare them. Here's an insert, right? We're going to make sure that the entity does not equal null. Good to know. We're going to add it to the data collection and return it. Here's an update, sort of the same way. And it looks like I didn't need this here because I have an await here. Okay, so we need both the entity to update to be non-null, but also the ID property because we're going to pull that out. So here we're getting the ID of the object because we haven't passed that in with ID property get value on that entity. So that's going to return whatever the primary key value is. And then we're going to call getById to get the actual entity because we want the entity that's in our collection. This one might not be the exact same entity, and it probably isn't. So we want to make sure that it's the same as the one that's in our collection. So after we pull that out of the collection, we want to make sure it's not null. We're going to get the index of it in our collection, and that's how we can replace it or update it easily in the collection. So let's add that manager to start up configure services, and we're going to need to qualify these. There we go. Now check this out. We're adding as a singleton, which is important, right? Because there's only one source of truth, a memory data manager of customer with the parameter. We create a new memory data manager with the parameter of ID property name equal to ID. So that tells the manager which property is the primary key. Okay, let's add a controller here. So to our controllers, we're going to add in-memory customers controller. So now you can see here that we're injecting the memory data manager of customer, right? So that's the one that we added as a singleton service. So there we have access to it. And now in our methods, such as delete all, we can just call that customers manager, whatever, delete all. Now, notice that we're using task of action result. And in fact, here on get, which is get all essentially, we're returning a task of action result of API list of entity response of customer. All right, so that list of customer is down in there. So we do a customers manager get, which gets our data, the result. And if there's no exception, then we're returning OK, which is our action result of new API list of entity response of customer, setting success to true and setting the result into the data of that API list of entity response. So this shouldn't be new to you if you watched episode 16. This is exactly how we handled data being returned by API endpoints. So the rest of this should be old news for you as well. Okay, let's go to the client. We'll create a services folder, and in there we'll add an API repository, which will be a generic repository for all the data types that we need and all the different ways that we can access them. Here we go. Now the first thing you'll notice is we've got some squiggles here because we're using Newtonsoft JSON and we need to install that. So this is an API repository of T entity which implements iRepository of T entity. So again, that interface can be used, the same interface can be used on the client as used on the server. And that's really, really important because you want these things to match up. So as parameters, this is getting an HTTP client, which is already set up with the base address. That's why we need that. The controller name, so that we can use that when constructing URLs to access the endpoints, and the primary key name. So here's get all, where we're returning an IEnumerable of T entity. So even though we're getting back from the API an API list of entity response, we don't need to pass that on to the consumer of this API. They just want the data. They don't need to know what happened with the API, right? So we're just calling getAsync with the controller name and getting the response and deserializing that response to an API list of entity response of T entity, checking to see if success is true, and if it is, returning the data. If not, I want to return a blank list, not null, but a list with nothing in it. It just makes sense to me. And then, we have try catches here. So whatever you want to do here, if you want to do some logging, if you want to report something back to the user, whatever, you can do that here. And the rest of these should be no surprise to you. The thing that's interesting is that notice that this is all generic. Like, we don't have anything about a particular class in here. We know what the ID is, we know what the ID property is, we know what the controller is, and we know what entities we're returning. We don't need to know anything specific about the API endpoints. And again, if you saw episode 16, this should be old news to you. All right, in that same services folder, we'll add an in-memory customer manager. So this is going to implement API repository of customer. And take a look at the constructor. This is where everything happens. So we're going to add this as a service in program. And when we do that, we get the HTTP client that is defined in program with the base address. So that gets injected. And then we call our base constructor. We send the HTTP client that was returned. And we also set the controller name to in-memory customers, which we've created. And then ID is the primary key name. So now let's go to program, and we'll add this manager on the client side. Make sure we have the namespace. And we're good to go. But before we can write any Blazor code, we have to do what? Add the using statements to _imports. Just to make it easier on ourselves down the road. So we have our shared models and we have our client services. Now we can hijack index. All right, I'm going to run it first and then we'll go through the code. That makes sense, right? Okay, so let's take a look here. We've got 4 customers. This is the ID right here, 1, 2, 3, and 4. Their names, Isadora Jar, and emails, in this case, isadora@jar.com. Just some silly names that I made up. Now I've got some operations here. We've already executed add and get all. So the first thing we did is we added these 4 customers, and then we did a get all to return all of the customers. And that is what you're seeing bound here. Now, update Isadora is going to change Isadora Jar's email address. So let's watch that. You see that? It went from isadora@jar.com to isadora@isadorajar.com. Okay? Now, I have 2 deletes, one for Rocky and one for Hugh, because there's 2 ways that we can delete a customer. One is by ID, and the other is by entity. So let's try Rocky first. Yep, there he goes. And now let's delete Hugh. Hugh Jass. Hugh Jass, good friend of mine. I like the Jass family. They're good people. And the next one is a get by ID demo. So this gets Jenny. We pass in her ID and we try to get an object back. And we did that, and it tells us what the ID is. And then we just have a reset. Now what's interesting is, let me do all these things again. If I go to counter and I come back, everything gets reset anyway. If I close it and I come back, everything gets reset. Watch this. There you go. Isadora is now Isadora@jar.com once again. And that is because we're not persisting it anywhere, right? Okay, so I just wanted to show you the basics of how we go about doing this before we move on to blob storage. Now, let's go through this code. We have a list of customers right there, customers. We have our Jenny message, which is just a string. Let's start with on initialized async. We're calling add customers. So add customers is first going to do a delete all and clear our customers. And then we're going to use insert for all 4 of these customers. And then we're going to call reload. And reload is just what you think it is. It clears Jenny message. It gets the list from get all. If that list is not null, remember, this is an IEnumerable, so we're going to convert that to a list and invoke status changed. So delete Rocky. Here's Rocky. We're getting him from X in customers where the email is blah, blah, blah. And if Rocky is not null, we call customer manager delete, passing the entity. Delete Hugh is a little bit different. We get Hugh from the list in the same way, but now we're passing Hugh's ID. Right? So I just wanted to show how you could either use the ID or you could use the entity itself. Here's update for Isadora. We get Isadora out of the list and we change her email and then call update and then reload everything. Get Jenny is where we're exercising get by ID. So we do actually pull her out of the local list. And if she's not null, we get Jenny from the database, well, from the server by ID. And if Jenny is not null, then we actually show her with the ID that comes out of the database version. Now let's talk about blob storage. So I've created a storage account on Azure. In fact, I've created an Azure account just for Blazor Train stuff. So here's a storage account that I created called Blazor Train. And the first thing we need is a connection string that will allow us to write to containers and all of that stuff. So if you scroll down here on the left, you'll see access keys right there. You click on access keys. Now you can see them in a list here. And this one right here, the first connection string is the one we want. So click on show keys and that will give you a copy button. You can copy that right in. All right, put that in a safe place. Now, if we go back and then scroll down to containers right there, you want to add a container. And I've already created one called customers, but this is how you do it. You can click on this plus container right there. You have your container name over here, and let's just call it, my container. And if you want anonymous access to it, which you probably do, maybe you don't, but for a podcast, it makes a lot of sense. You want to use this option right here, a blob for anonymous read access for blobs only, right? And it's going to give you a little warning here. It can be read anonymously, but you can only add to it if you have access, and hit the create button down here. So that's how you create a new container. So I'm going to just go ahead and delete my container because that's not the one I'm using. I have created one called customers, and this is the container that we're using. Now there's nothing in it, but I'm going to leave it up because once we start adding stuff to it, we'll be able to see it. All right, so I still have in the clipboard the connection string to my storage account. So back in the application, we're going to add a very particular version of Azure Blob storage to my server project. And it's version 11.2.3, which is the last of version 11. It's the last subversion of 11. The reason I do that is because 12 and higher, or at least the current version, doesn't give me a way to upload a file in a chunked manner where I actually get an event I can handle after every chunk. So in other words, I can't do a progress bar for uploading. You just have to wait until it's all done. It's kind of black boxish, and I don't like that. At least I haven't found a way to do it. And there's nothing in the docs that shows you how. It's just, here's the maximum size, one line of code to upload a file, to upload a blob file, and then you wait. And so you really have no idea what's going on. You just sit and wait. So in our podcast administrator, sometimes we're uploading files to Azure Storage that are, 50, 60 megabytes or more. I mean, the WAV files that we record can be over 200 megabytes. So we really want to see that, status as we're uploading. So that's why I chose to use 11.2.3. Now, the code and the object names are also completely different with this older version, this deprecated version of Microsoft Azure Storage for Blobs. So got to be careful with that. Now, I've got a helper class for Azure Storage using this version called Azure Storage Helper. So let's add that to data. So this has got some stuff that we're not even using in this demo in here, but there are things that you could probably use yourself if you're uploading data to Azure Storage. I think I've even might have shown you this in a previous Blazor train, but I'm not sure, so I'll go over it again. In the constructor, we're passing in the blob storage connection string. We can do that in startup and pull the connection string out of app settings. So that's coming up very, very soon. So here's our upload event handler, which has our %complete. It's very nice for that. Uploading a file in chunks. We have an open container that we can use. We pass the container name and we can open a container, and that's what we can use to upload it. Now I also have get unique file name, which uses is numeric. So these are kind of helper things that you might need to use at a later time, but not necessarily here. Okay, so now that we have this, we can create a blob data manager using our iRepository. So let's do that here. Blob data manager. All right, now we're really getting into it. Look at all these things here that we have to set. Here's our data, new list of T entity. Here's our property info for ID property, just as before. We have the ID property name, the Azure Storage Helper. We also have this semaphore slim. And this is sort of a more sophisticated locking mechanism than just lock. And it works asynchronously. It's great. So this is how we're going to lock access to writing the blob files, the JSON files. In the constructor, we're sending the Azure Blob connection string, the storage connection string, the Azure parent container URL. So this would be the URL that somebody would use to access those JSON files, minus the container name. This is just at the storage level. And then your container name, your ID property name, and minutes to cache. So I just have this set at 5 because that means if we go to retrieve some data and it's been 5 minutes since the last update, then we would read from the blob storage again. Otherwise, we'll just read what's in memory. So basically this is saying, hey, we're going to cache everything that we're returning in this manager for 5 minutes. Of course, that is up to you, how much cache time you want. All right, so this is well commented. I'm going and creating all of these things here and pulling them out, setting our local properties. Here's the Azure Storage Helper, which we're creating with the Azure Blob connection string, which we got from here in the constructor. We're creating a JSON folder for storing the local JSON files, because we have to have a local file before we can upload it. So that's in our current directory. JSON, and if it doesn't exist, we'll create it. And then look at this, the data file name is the data folder, and then the entity name .json, right? So if we have a bunch of different entities, we want to put them all in one container, we can do that. And now we're using this method to call load data asynchronously. Now load data, creating a new HTTP client. We're setting the URL from the Azure parent container URL and the container name. That means that there must be a / at the end of Azure parent container URL / type of entity .name, so customer.json, right? And now we're pulling that down, right? We're loading this up. We're loading the data. So we're pulling that down as a JSON. And then we're getting that data and we set the access time. Now, here's where that semaphore slim comes in. And this is really, really important, guys. Even though this is a singleton, we could still have people competing for access. Multiple clients through the web are accessing this at the same time. And so this ensures that when we're saving, that we're waiting until somebody else isn't saving, right? So this is the rare chance that two people are going to save to the data at the same time. So await semaphore slim wait async, and then in the finally we're doing semaphore slim release. And in between here, we're converting the data, we're serializing it, we're writing it to the local file, we're uploading it to Blob storage. Now let's go to our app settings file. So Azure Blob connection string is the connection string that I got out of the portal, and my Azure parent container URL is based on the default Azure pattern for storage accounts. So it's blazortrain.blob.core.windows.net. Now let's go to startup, and we need to add the manager, the Blob data manager for customers. So here's our, if you remember, the first one was the Azure Blob connection string. We're pulling that from configuration. And the parent container URL also pulled from the configuration, which comes right from the JSON file we just edited. Here's the container name, customers, and the primary key name, ID, and the number of minutes for caching, 5. All right, now we can write a customer's controller, which is going to read from blob storage. And this controller is going to inject our iRepository of customer, which happens to be our blob that we just set up in services, our blob manager. And so that's our customers manager, and we're going to use that in much the way we did before with the in-memory controller. It's the same GUI inside, right? It's pretty much a cut and paste operation. So now that we've got that on the server side, let's add a manager to the client side, which should be just a few lines of code. So here's our customer manager, which inherits API repository of customer. And just like before, we're passing on that HTTP client. We have the name of our controller, customers, and the primary key name ID. Now we need to inject a customer manager into our client. We need to set it up as a service anyway. So go to program. There you go. Services add scope customer manager. Now we can use that in a Blazor page. So let's add one called Blobs. And rather than just changing what we already have, I wanted to make different pages for each method so that you'd have something to refer to. This is pretty much all the same, except instead of the in-memory manager, we're using the customer manager, but it's the same interface, so the code is exactly the same. The only thing that's a little different, I think, here is on initialized, we're calling reload first, and if the customer's count is 0, we're then calling add customers. We don't want to just go ahead and call add customers every time we hit the page. We want, because we're persisting the data, right, in blob storage. So now we want to load it first, and if there's nothing there, then it's the first time. Now we can create the customers. Other than that, it's about the same. Now let's take this opportunity to update the nav menu, because we want to get rid of the counter and fetch data. We don't need any of that. But we are going to have 3 pages. We've got our in-memory, which is our home page, our index. We have blobs with integer IDs. In other words, the customer class, the customer model, the ID property is an int32 or an int, right? But we're going to do another one where we create a class called customer with GUID ID. And it's the same thing except ID is a GUID. So I want to show you the ability to use both, be a little more flexible. But we'll do this next after blobs. All right, I think it's time to run this and see what happens. So here's our customers container in Azure. There's nothing in it. Now let's go to our blobs page. There's going to be nothing there, so it creates the blobs. And now if we refresh over here, look at that, customer.json. See? So we've written a blob into that container. And notice now the time, 2:24:50. Let me update Isadora, which should update this. And now this should change if I refresh the date time, the modified. Yep, it sure does. And now I can do some deletes. Let's delete both of these guys. And you know what? Just for fun, let's close this and bring it back. And there you have it. Isadora jar is changed. Rocky and Hugh are gone. All right, on to the next thing, which is changing up the model to have a GUID as an ID. So we need a new model, and this is going to be called Customer with GUID ID. There you have it. The ID is not an int, but a GUID. Okay, let's go to Startup, and we're going to add a new iRepository of customer, but instead of customer, it's going to be an iRepository of customer with GUID ID. And look, everything else is the same, right? We've got the same configuration, the same URL, the same container, the same name, ID, and the same timeout value. Let's create a controller. Customer with GUID IDs controller. Okay, now everything here is the same except wherever we had customer, we now have customer with GUID ID. There are a couple other differences. Namely, when we do a get by ID, now we're passing a GUID, and our delete by ID is now accepting a GUID. But all the other code is the same. Let's go to the client and create a manager for it. So as you can see, this is pretty much the easy part. Pretty self-explanatory. Now we have an API repository of customer with GUID ID, and the name of the controller is customer with GUID IDs. Add that to our program, the manager that is. Now we can create a new Blazor page to use that in. Now here we're using a tried and true technique for creating a random GUID with a new GUID method. We have a new object, we get the hash code, we seed a randomizer with that, we dump random bytes into that array and create a GUID from those bytes. You're going to see that here when we're adding, right? We're saying the ID instead of 1, 2, 3, or 4, we're just calling new GUID. Everything else is the same except that we're now using a customer with GUID ID manager instead of the other managers. And again, we'll pull up the customers container to show that when we click on blobs with GUID PK and refresh, now we have another JSON file there, customer with GUID. We can do the same stuff here. Watch this email address. There it is, that changed. We can delete by entity, we can delete by ID, we can get Jenny, and there it is. And just to show that yes, it is persisting, we'll run this again. Boom. Okay, now this is normally where I would stop and say, go get it, but I do have one more thing to share with you. And that is, in episode 16, we created a repository for Entity Framework that used the iRepository pattern. And since the iRepository interface has changed a little bit, I thought I would include a newer version of that with this code base that's in the GitHub repo. So to do that and to handle that, we need to add some packages to our server. Right? We're using Entity Framework Core SQL Server tools and the code generator stuff in Visual Studio. You need this to do some scaffolding. Now, I'm not going to do a demo with it, but I will share with you an EF data manager that you can use on your own. So let's go to Data, and we will add EF Data Manager. Okay, so the EF Data Manager, taking a look at the signature here, is of T entity and T data context. Then we're implementing iRepository of T entity and also iDisposable. And our wheres are T entity is based on a class, in other words, anything, but T data context is a DB context. We're also setting the tracking behavior to no tracking. This is something that I've become accustomed to with web stuff, using Entity Framework behind websites. You want to turn tracking off because you basically are just using it to do reads and writes, and you don't want those hanging around. Tracking is more attuned to stateful applications, such as, desktop applications, that kind of thing. So this is implementing all of the methods except for this one, delete all. Not implemented exception. This is not a good idea to do when you've got a live database. So we're just saying, sorry, you can't do that. But we do have to have a delete all method because we are implementing the interface, right? And so this is where this filtered get really shines, is when you're using it against a database. So again, I'm not going to show that, but I wanted to include it because it is an updated version of what's in episode 16, data access. And again, you can find everything on the GitHub repo, which Carl back in the studio is going to tell you about right now. If you're interested in this code, or even an updated version of the code from episode 16, data access, you'll find it at this GitHub repo right here. Hey, thanks for riding the rails with me today. This is where I jump off. I'll see you next time. Blaze the train!